A story of life and death 5,000 years ago is revealed to researchers in England. Through new tools that extend human vision, the lost past comes into sharp focus. This extraordinary vessel will carry explorers into the once unseeable world of the atom. Traveling at near the speed of light, scientists seek clues to an event we can barely comprehend, the origin of the universe.
5, 4, 3, 2, 1, now.
The landscape hidden within the human body is charted by a medical pioneer. Through a fusion of new visual tools, we can see inside a beating heart, a vision that may one day save thousands of lives. On a remote desert plain in New Mexico, an array of earthbound sensors decodes mysterious signals from space. They reveal an invisible universe still expanding in unimaginable violence. Tonight, come with us beyond the limits of human sight. Travel among the stars, into the micro-world, and through the human universe within us all. Journey with modern explorers on a mission to see things as never before. Join us on a voyage to lost and unseen worlds.
Because there is always knowledge to be gained, new paths to explore, and mysteries to unlock, the Infinite Voyage is made possible by a grant from Digital Equipment Corporation.
No world is further from our grasp than the ancient human past. Yet today, science can now see and reconstruct life histories 5,000 years old. Beneath the pyramids in Egypt's Nile Valley, the tombs of the elite have been emptied. What remains are the lavishly decorated walls that speak of splendor and ancient glory. The tombs were emptied by expeditions in the 1920s and 30s to save the contents from treasure hunters. Archaeologists from museums around the world would also rescue human time capsules. Ironically, their contents were barely examined. These were the Egyptians themselves. Those who believed that after death, their souls could again enter the world of the living. Preserved by an ingenious process of mummification, their bodies hold the secrets of how they lived and died. In a Victorian museum in Manchester, England, their story is slowly being pieced together. Here, 20th century imaging techniques are opening the door on an unseen world lost in the folds of time. Sophisticated new techniques are being used, not only to analyze the mummies, but to actually reconstruct their lives. The Manchester collection includes 21 mummies, an intriguing cross-section of the ancient Egyptian upper class. The long-held view that they led lives of ease is being challenged by a team of researchers led by Rosalie David.
The ancient Egyptians left behind some wonderful paintings in their tombs and objects in the tombs, which give us a very one-sided view of their society. Now, the mummies give us a different view of this because they show the kind of diseases that the people suffered from. So one of the things that the Manchester Project has done is to introduce these virtually non-destructive techniques of examination.
After several thousand years, the remains of this woman are extremely brittle. To probe her body with a scalpel would ultimately destroy it. Instead, pathologist Edmund Tapp employs a highly sensitive instrument called an endoscope. Tapp's probe into the lung reveals particles of sand embedded in the tissue.
Oh, yes, now that's a good. I'll just put that.
Similar to black lung disease, this condition may have caused her death. Today, pathologists also rely on brain tissue for evidence of disease.
There's quite a lot in there.
Most of the brain was removed by ancient embalmers.
The alternative would be to drill a small hole in the back of the skull and take some out through there. Ah, good, excellent.
But even this small fragment tells a story. Incredibly, after 5,000 years, the tissue can be rehydrated and sliced into thin sheets for analysis. Magnified 25,000 times under a powerful electron microscope, the brain tissue yields a new clue.
There's no doubt that the ancient Egyptians had their problems, particularly with infectious disease. We found evidence of a worm called strongyloides in the small intestine of a mummy, and several other infectious diseases.
A parasitic worm, probably ingested from drinking water, eventually lodged within the brain, causing coma, then death. From an X-ray of the skull, researcher Kathy Asher uses computer technology to learn even more about the Manchester mummies. In the structure of its face and skull, each mummy carries the clues to its racial and family history. By measuring each feature precisely and comparing it to others stored in the computer, Asher has been able to identify several of the mummies. A computer-drawn image not only provides a database for archaeologists, it forms the framework for a process that will bring researchers face to face with the past. A medical artist shapes the features of a mummified priest. Today, we may now understand the ancient Egyptians not as phantoms, but as people. Men and women whose faces reflect both the suffering of life and the vision of eternity. New visions are not only shedding light on the past, they are also shaping the future. At the University of Illinois in Champaign-Urbana, artist Donna Cox works with David Onstad to visualize a 20th century plague.
So we can get a better look at, well, see this area right here?
At the university's Center for Supercomputing Applications, artists and scientists are coming together to create unique pictures of worlds that cannot be seen in any other way.
Over time, now that we have this time dimension, we can go through an entire season and see this take place over large areas.
Using his data, Cox programs the computer to generate a cornfield overrun by destructive insects.
Take a look at this field over time. Now take a look.
So as the epidemic occurs, we should be seeing the green at first, representing the healthy individuals, and then the red appearing.
The team now introduces a microorganism to kill the insects, proving this method can save crops worldwide.
I saw that earlier, and
Working with Matt Arrett, Dr. Klaus Schulten from the University of Munich is studying the complex process of photosynthesis.
These ones here are also colored.
here you'll see that the variation that I've given to the background. So it won't connect with any of the colorations of the molecules.
For the first time, he can see the molecular engine that converts sunlight into chemical energy.
It looks good. You can differentiate very well the atoms. They look very sharp, and you see the structure very well. I like it. That's good.
Atoms of different elements are assigned different colors. By modeling their location and exposing them to computer-generated sunlight, Schulten can measure subtle shifts and changes in the molecules never seen before. Now he can actually see the workings of this chemical factory that supports life on Earth.
Artists have always been attempting to look at the universe as one side of a coin, while the scientist is looking at the universe on the other side. But it's the same coin that they're investigating. It's the same principles of nature, in a sense.
The information is fed into a computer so powerful, it can read the entire New York City phone book in 1/10 of a second. But without the artist, the data it generates would be nothing more than a list of numbers. Donna Cox.
The data is actually computed on the supercomputer and then networked over to a workstation to use color to visualize the data.
Using a palette of 1,000 colors, Cox now sets to work to image a mysterious object in space. Far beyond our solar system, astronomers have captured this faint picture of 2 great oceans of superheated gas. Little detail of this cosmic blowtorch could be seen until now. The dynamics of this powerful jet emerge, driven by the physical laws that govern the universe. Computer models have now become an important tool for testing and revising scientific theories about the real world. Operations Manager Nancy St. John.
Aside from the fact that this is accelerating science, I think one of the key things that we're doing here is we are giving a common ground to all scientists, a new language, a new place where they can share information, where they can talk together in a new way.
With the precision of a Bach masterpiece, this dramatic fusion of science, technology, and art reveals exotic worlds. The genetic code is detailed in the famed double helix of DNA. Computers allow scientists to study the complex processes that shape the Earth. A chain of volcanic islands rises from a synthetic sea. We can safely fly into the hidden eye of a hurricane and explore the deadly dynamics of a tornado. Long before launch, the flight path of Voyager is rehearsed in exact detail. But far beyond the reach of Voyager lays the great unseen universe. Exploration of this remote frontier began with a chance discovery a half-century ago. In the 1930s, the first attempts to communicate across the Atlantic by radio telephone were interrupted by unexplained noise. It came from radio waves in space.
Boston, Massachusetts.
Today, the discovery is revealing a surprisingly new and unseen universe. On a remote desert plain in New Mexico, the largest radio receiver on Earth is positioned. Airline pilots call it the mushroom patch. Scientists call it the Very Large Array. When spread along 38 miles of railroad track, these dishes mimic a single telescope the size of Washington, D.C. "24 hours a day, they are trained on the sky to intercept and decode messages from space. This data is sent to powerful computers in a central control facility. Within this nerve center, the performance of these sensitive instruments is constantly monitored.
Let's check it out. What's that now? It's running between 15 and 16 degrees. I may take another look at 6.
Astronomers journey here from around the world, not to listen, but to see pictures that can now be created from radio noise. The total energy of all radio waves ever recorded barely equals the force of a single snowflake hitting the ground. To gather these incredibly faint signals, the dishes are carefully arrayed to track objects deep in space. Bernie Burke, from the Massachusetts Institute of Technology, is a frequent visitor to the Very Large Array. To illustrate how radio telescopes can detect new phenomena, he looks to our own solar system. An optical image of the planet Jupiter taken by the Voyager spacecraft. Burke now calls up the radio image of the same planet. What emerges is a belt of radiation invisible to optical telescopes.
In addition to the thermal radiation from the disk of the planet, you also see a strange structure on either side that's completely unlike anything you can see in an optical picture. The radiation is coming from the radiation belts of the planet, the Van Allen belts of Jupiter, very much like the radiation belts of the Earth, but far more intense. The radio astronomer, when he sees this, would be very excited because nobody had predicted that the planet Jupiter has any such phenomenon.
The Orion Nebula, a virtual stellar nursery. Jolted by shock waves, titanic clouds of gas and dust merge. This primordial matter grows hotter and denser until finally new stars are born. In this way, our own sun was created 4.5 billion years ago. More dramatic than the birth of a star is its awesome death. This rare picture, made from radio waves, is of an exploding star. Called a supernova, it is one of the most spectacular natural disasters in the universe. In the past 900 years, only 5 of these extraordinary events have been seen in our galaxy. As a star burns the last of its fuel, it begins a dramatic collapse. Massive explosions hurl waves of stellar debris far into space. From these shock waves, new stars will be born, and the cosmic cycle of life and death will begin again.
The universe is not just a universe of stars calmly evolving over millions of years. There are also some very dramatic things happening, generating large quantities of radio noise, narrow jets of relativistic particles being beamed out into space, pulsars that are neutron stars whirling around sometimes 1,000 times a second, a world of violence, activity, and wonder.
Unexpected discoveries have also been found in the center of our own galaxy, the Milky Way. Here, astronomers have located a puzzling source of radio waves. Clues to the source of this invisible energy have been detected by the Very Large Array. Director of VLA, Ron Eakers.
One of the most mysterious sources in the radio sky is coming from the center of our galaxy. And that's an area in which I've been involved myself. When you look in light towards the center of the galaxy, and here's an optical photograph, you see these black and white patches. That's because the dust blocks the light from the center, and we can't get any picture of the center of the galaxy. Well, soon after the VLA was completed, some colleagues and I got one of the first images of the very central region. And here we had another surprise. We saw this spiral structure, and this turns out to be the source of fuel for the engine in the galactic center.
Under a great arch of energy, millions of light years across, is the center of the Milky Way. Deep inside its core, radio astronomers make an exciting find: a cosmic hurricane that emits tremendous energy. Once the domain of science fiction, radio astronomers now believe that within this spiral of hot gas is an object with gravity so intense it distorts everything we see around it. Called a black hole, it consumes entire stars and everything else nearby. So incredible is its pull, not even light can escape. The idea of a black hole in our galaxy may be an unsettling thought, but for scientists, it's a unique opportunity to observe one of the great spectacles of the violent universe. Through ingenious sensors like the Very Large Array, astronomers have unveiled new and violent realms. We may now ponder mirror images of galaxies and stars without ever leaving the confines of Earth. But based on what we now know about individual galaxies, a more profound question can be asked. Do the galaxies form patterns in space? Is there an unseen fabric common to the universe? On a mountain peak near Tucson, Arizona, a highly specialized optical telescope is readied to probe the night sky. Designed to observe the most elusive objects in space, it can take us to galaxies 1,000,000 times dimmer than the stars we see at night. Across the valley stands an older, less powerful instrument. Together, these telescopes will serve astronomer John Huckra as he begins a landmark scientific survey. His lonely vigil will last for 40 days and nights, spread over 6 months. Huckra will use the telescopes to track the movements of distant and far-flung galaxies. One of the great discoveries in astronomy is that galaxies appear to be speeding away from us in all directions. As they recede, the color of their light is shifted to red. By measuring this phenomenon, called the red shift, Huckra can determine the speed and location of each galaxy. From painstaking analysis of light from these objects, Huckra calculates their distance from Earth. Eventually, he will plot the location of over 1,000 different galaxies. From his coordinates will come the first three-dimensional map of the universe. In Cambridge, Massachusetts, at the Harvard-Smithsonian Center for Astrophysics, the results of Huckra's survey are modeled by the second member of the team, Margaret Geller.
For at least 2,500 years, we human beings have been busy making maps, which represent what we know of the world around us. We've made maps of the Earth, we've made maps of the Moon and other planets, we've figured out the organization of our planetary system, and we've gone to increasingly larger scales. And now, one of the challenges of modern science is to map the structure of the universe itself. And the edge of this shell, which is well separated in space, and it's hard to see that on the 2D
it's
plots.
very hard to see.
Geller and Huckra's map covers only a small slice of the universe. Yet when completed, the astronomers were startled by the results.
This is an example of the way we display the data to have a look at it and try to interpret it. The remarkable thing is that we have found that there are striking patterns. There are big regions where there are no galaxies, like this big void. And if I connect the points around the edge, the galaxies which lie in the sheets surrounding these voids, I can see very well where the huge void lies. There are big empty regions in the universe which have no bright galaxies in them, and they're surrounded by galaxies which are on thin sheets surrounding these vast empty regions. So there might be thousands of galaxies, each one like our own Milky Way, surrounding an enormous dark region which extends for maybe 100 or 150 million light years.
What cosmic forces could have created this newly discovered architecture? This extraordinary new map poses more questions than it answers.
What's inside these enormous dark regions? Is it full of some dark, non-interacting matter that we can't see? Are there faint galaxies there that just aren't in our surveys? What is it? What is the dynamics of these regions? How did they get to be so big?
If our surveys keep revealing structures that are larger and larger, if we see structures that are large on the whole scale, the horizon scale of the universe, we may have to rethink all of our basic ideas about the Big Bang model, because that may not be right.
And you really had the feeling that people must have had when they first explored unexplored regions of the Earth. There was this feeling that we are the first human beings ever to see this striking pattern. We are really the first to discover this. And look at the message that it brings.
From a small outpost on the top of a mountain, Geller and Huckra have discovered evidence of a wondrous structure. What once seemed a random collection of lights in the night sky may now give us a glimpse of the evolution of our universe, and perhaps its fate. Today, we break the bonds of gravity and cast modern miracles into orbit. Satellites relay global communications, monitor our weather, and discover resources hidden within the Earth. Data from space is transformed into this picture of San Francisco Bay. The computer has been programmed to distinguish the difference between land and water. Technology developed to explore the heavens is also being harnessed to see within the human universe. 10 years ago, Michael Vanier was an engineer at NASA, where this imaging technique was developed. Today at the Mallinckrodt Institute of Radiology in St. Louis, he uses the same technology to create complex medical maps of the human brain. In a medical breakthrough, he is programming the computer to identify and classify tissues, to look for signs of early disease, and to locate tumors. This mapping system requires a new cutting-edge technology borrowed from radio astronomy. It is called magnetic resonance imaging, or MRI. The machine creates a powerful magnetic field that actually realigns atoms within the body. This motion produces a faint radio signal. These radio signals from human space are translated into dramatic images. MRI now allows physicians to diagnose disease with greater accuracy and may further eliminate the need for exploratory surgery. New mapping techniques have already given Dr. Patrick Kelly a head start in a revolutionary new procedure. At Minnesota's Mayo Clinic, he will attempt to remove a tumor from deep within his patient's brain.
Let's do it on the MRI now, wouldn't you think?
Earlier, Kelly planned his strategy with a computer scientist. Using images of his patient's brain, he first isolated the tumor.
There's our target point there. Looks pretty good there. It's actually under that internal cerebral vein. Now we got to pick an avascular entry point. Let's see. Let's try it right about, maybe go in between those two arteries there, and there are no veins there. So collar angle of 31. Well, that'd be a nice, comfortable angle to work at. That's what I see, 2. Okay. Well, before, the problem is the surgeon would get lost right on the surface of the brain, and the approach to a deep tumor was very, very hazardous. Where now, with the system keeping us oriented, we can not only approach and localize deep tumors, but can remove them.
The patient was fitted with a special head frame while the images were taken. With these reference points, Kelly can plan his surgery with precision never before possible. The computer allows the surgical team to align their operating microscope precisely where the incision will be made. The tumor will be removed by laser beam. The patient is again fitted with the head frame. The coordinates on the head frame indicate the precise surgical angle. A low-intensity laser beam marks the point of entry. The operation can now begin.
I think the most satisfying thing is to have a patient who's been all over the world being told that they have an inoperable tumor and be able to take that tumor out. And that's the most satisfying thing to me, to be able to bring all this technology together to the benefit of a patient.
Operations on deep tumors were rarely attempted until Kelly invented this technique. Now, by mapping the hidden world within the brain, Patrick Kelly is beating the odds. The study of medicine was once limited to what we could see. 100 years ago, even a simple operation was a life or death proposition. In unsanitary operating theaters, patients were exposed to the scrutiny of would-be surgeons. Today's future doctors at the University of California, Los Angeles, study maps of the human contour at little risk to the patient. New digital X-rays are replacing conventional techniques. They require far less radiation to make an image. The body can now be examined in sharper detail. Stored on optical discs, the X-rays can be quickly retrieved from a space-age chart room. Linked to hospitals across the United States, doctors around the country now have instant access to information critical to diagnosis. Today, it is even possible to create three-dimensional X-rays. Pictures so detailed and so accurate, they can be used to probe the body without surgery. These images present breathtaking views. Exploring the spinal column for defects can be hazardous to a patient, but now the spine can be opened by remote control. Prior to an actual operation, a doctor electronically removes an arm bone from its socket. Miraculously, without surgery, a hidden fracture is revealed. Medical pioneers have taken three-dimensional X-rays a step beyond. In Santa Clara, California, these pictures are being used to help create new or missing bones. Reconstructive surgery often involves painful grafts and considerable guesswork. Such is the case with this piece of skull, crushed in a motorcycle accident. Frustrated by these procedures, Dr. David White applies a new technique.
This is a patient who's missing a frontoparietal area on his cranium secondary to surgery.
Today, White designs a replacement that will exactly match the contours of the skull.
Computer to fill that in. You can see it's down here in the temporalis fossa. Comes up over the orbital rim and the whole way high onto the frontal area. He changed the light source for me, so
he decides on a strategy that takes advantage of the body's natural symmetry.
Great. I think that mirroring will be the way to go with this.
Mirroring is a nice way of being able to use the pig plant looking on the same plane.
By duplicating the opposite side of the skull, the computer designs the exact shape to fill the missing area.
See what kind of symmetry we can get. That's great.
Guided by the computer, an ultra-precise milling machine creates a mold. Exact to less than a millimeter, the mold will be filled with a special plastic to create a synthetic implant.
Now when we go to the operating room, we have a 3D image of the patient, and we can, in fact, have a model of the defect with us. We perhaps have operated on that model ahead of time that we know is going to fit that defect like a piece in a puzzle. So we now have a blueprint for surgery. You know, suddenly out of the miracle of the computer, we have something that is precise and is like a glove. It just goes right in, and it's gratifying and always exciting every time.
Every year in America alone, 25,000 children are born with congenital heart disease. Dr. John Laschinger at Washington University Medical Center in St. Louis has taken a bold step in their behalf. The standard technique for diagnosing heart disease involves a painful procedure. A catheter releases dye into the heart.
That's right. A lot of
The dyes reveal obstructions in the coronary arteries. John Laschinger was determined to reduce the need for this traumatic procedure. Using MRI scans of each phase of his cardiac cycle, he created a three-dimensional motion picture of his own heart. With images like these, doctors hope to perform the diagnosis electronically and eventually eliminate a painful and dangerous operation. "400 years ago, Leonardo da Vinci was among the first to make detailed drawings of the interior of the human body. From careful dissection, he discovered the complex world within. How far we have come since Leonardo. Like scientists today, the ancient Greeks sought to travel beyond the boundaries of sight. They believed in great and powerful gods who ruled the heavens and the earth, but they also believed in the power of thought. Today we come still lured by the remnants of this once glorious civilization. "2,500 years ago, against a backdrop of myth and superstition, a few brave thinkers turned away from the gods. Fascinated by the beauty around them, they thought the world could be explained not by the supernatural, but by laws of nature. One of the most profound ideas was that a world existed beyond what the human eye could see. A world filled with minute particles they called atoms, the common building blocks of all things. From the simple observations of the ancient Greeks came the first glimmerings of scientific thought. 2,000 years later, the notion of the atom would become a reality. Today, we can travel into the world the ancient Greeks could only imagine. The newest voyager to the micro-world is the scanning tunneling microscope. Inside, a needle 10 million times smaller than a human hair scans the landscape. It hovers just above the surface to create pictures of incredible resolution. At the Thomas J. Watson Research Center in Yorktown Heights, New York, scientists can see extraordinary landscapes. What looks like a photograph of the American Southwest is actually the surface of a piece of silicon, 1 million times smaller than the point of a pin. The surface of a computer chip, seen from above, resembles rolling hills and valleys. Now the microscope sweeps even lower, across the electron shells of individual atoms. Visible are the actual bonds that hold them together. As amazing as these pictures are, they leave us only on the shore of another unseen world, the world deep within the atom itself. To travel inside this realm requires extraordinary technology and imaginative explorers. In this search, Leon Lederman believes that childlike curiosity is a scientist's greatest tool.
little kids, as soon as they learn to talk, they're all scientists. They're all scientists. They ask exactly the right questions. You know, they say, why is the sky blue? They say, what keeps birds up in the air? They keep asking questions. Parents shouldn't get upset because you send them to school, and pretty soon the teachers in the school will beat all this stuff out of them, and they'll hew to a more sensible line, and they'll stop asking questions, and they'll grow up to be good, useful citizens, lawyers and policemen, and so on. A few of them will be ornery. They'll refuse to grow up, and they'll be physicists, or maybe even poets.
In a cathedral-like structure just west of Chicago, 2,000 researchers and technicians work around the clock to probe the world within the atom. Beneath this 4-mile circle on the Illinois plain, one of the most incredible dramas in science is acted out. The Fermi Particle Accelerator Laboratory honors Enrico Fermi, one of the first to split the atom. Led by Leon Lederman, scientists now come here to split particles within atoms to expose the inner workings of the universe.
Okay, go ahead and do the P0 new start.
Pieces of atoms called protons and antiprotons are violently accelerated, then smashed together.
5 minutes before the shot. This was a half an hour before it moved.
Somewhere in the debris, researchers hope to discover an even smaller particle. The protons and antiprotons are shot in opposite directions through the 4-mile tunnel to collide head-on. Collisions are rare. If they could be seen, Fermilab would resemble an atomic demolition derby. It is a simple strategy that requires mind-boggling precision. Firing protons and antiprotons at each other around the ring has been compared to firing bullets across a shooting gallery the size of Texas, hoping they will collide.
The total energy invested in this collision is about equal to the total power generated by all the power stations on the planet. That's a ferocious amount of power. Of course, it only lasts for a very short amount of time. But during that brief instant in which this enormous energy is collected, it's collected into a region of space which is about 100,000 times smaller than the size of a proton. So you've created an intense cauldron of energy for that brief instant of time.
In this 2,400-ton detector, the protons crash together. Invisible to the human eye, the debris is tracked and recorded by delicate sensors that surround this core. It is an irony that scientists must use this 4-story-high microscope to find the smallest things there are. Tonight's experiment begins within this futuristic device. The first in a series of accelerators, it creates the proton bullets and fires them into the main ring.
Okay, 30 seconds until we inject.
After 2 weeks of near misses, the scientists are tense.
Orbit looks okay. 5, 4, 3, 2, 1.
Antiprotons are shot into the tunnel. They are guided by huge magnets within the tunnel walls. A second stream of protons is shot in the opposite direction. Together, they are accelerated to almost the speed of light. In under 30 seconds, the protons will travel 5 million miles. The scientists will keep them apart until the precise moment of collision. In the collisions of protons and antiprotons are the smallest particles known. Called quarks, they may be the most fundamental building blocks in nature. The experiment is a success. It has resulted in the largest number of collisions ever recorded at Fermilab.
That's one of those little neutron phones. I see. Yeah, you're seeing science in action, and what science is drinking champagne out of styrofoam glasses at 1 in the morning because somebody did something right.
Their achievement is just the beginning. Even with powerful computers, it will take months to sort through the debris of the collisions. The physicists hope to find even smaller particles, the forces that hold them together. In their search for the smallest particles in nature, scientists are virtually recreating in miniature an awesome event that occurred some 15 billion years ago. Out of nothing comes an explosion of unimaginable fury. The universe is born. Within moments, it expands and begins to cool, and matter begins to form. As the early universe continues to expand, titanic clouds of hot gas seed the beginnings of stars and galaxies. Even now, galaxies race away at phenomenal speeds, still propelled by the energy from what scientists call the Big Bang. In a tunnel beneath Illinois farmland, the world of the very small is linked to the world of the very large.
Gives you a glimpse, a very brief glimpse, it's true, but a glimpse of how the universe looked shortly after the Big Bang, shortly after the creation of the universe and the Big Bang. All the particles in the universe, all of the presently observed stars and galaxies and so on were concentrated into a tiny domain at this intense energy and intense density. And that's the connection between the ultra-small, the particle accelerators, and the ultra-large, the giant telescopes that have taught us about the universe.
Children ask why the sky is blue. Physicists question how the universe works. They share a common curiosity, the need to know. In the past, ancient mariners described a world fraught with danger and superstition. Beyond the horizon, they believed the seas fell into oblivion. Lured by unseen worlds that lay beyond, a few brave explorers would venture forth to challenge the horizon. Today, in our own great age of discovery, we are exploring worlds far beyond the limits of human sight. We have peered into the atom and found the common bond that links all living things to the Earth and to the stars. We have gone deeper still and glimpsed for one brief moment the beginning of space and time. We have journeyed within the living body, explored its architecture, and mapped the contours of the human brain. And still we reach to new horizons, to realms that challenge our ideas about the universe itself and our place within it.
Exploration is one that has been going on since man first wondered about the world he was living in and how it worked, and decided to give up magical explanations in terms of logic. And here we now are in the 1980s, beating our heads against the most baffling puzzle that has ever faced the human mind, it's still the same question. How does the universe work?
One of the attractions of finding something like this, that it always brings up more questions than it answers. There's always more to discover. And it's one of the wonderful things about science. You think you've come to an end, but there are brand new questions just around the corner.
And so this is just part of our inquisitiveness in wanting to know, what's happening? Little fellow, why are you so bright? What is it that's making it work?
It's an exploration of what you can see, and at the same time, occasionally, the opening up of new vistas that were never expected. And you just open the door, and there you are with something brand new that you have to explore all over again.
It is a search that started long ago. It is a search driven by human curiosity. For the more we learn, the more we need to know. The infinite voyage has just begun.
Because there is always knowledge to be gained, new paths to explore, and mysteries to unlock, the infinite voyage is made possible by a grant from Digital Equipment Corporation.